right, today we're going to start Module 11. Okay, we're going to talk about adding and subtracting polynomials. First, a little bit of vocab. What is a polynomial? How to classify them? And then we'll start talking about adding and subtracting. Okay, a polynomial is essentially just a monomial or the sum of two or more monomials. Okay, notice we can classify a polynomial by the number of terms. These prefixes should tell you monomial should have one term, binomial should have two terms, trinomial should have three terms. Okay. So we'll put 2 and 3 in here. Now, a monomial basically is just a number. It can be a variable or the product of numbers and variables. What is important to remember in order for something to be a polynomial is that the exponents must be whole numbers. Okay, so you can't have any negative exponents. So examples of monomials, we can have what it says, a number, so like 2. We can have a variable, x. We can have products of numbers and variables, or it can even look like 2x squared y to the third. Now, notice a product does not have any addition or subtraction. Okay, so once we see something like this down here, this is no longer a monomial. This has 3 terms, 1, 2, 3, whereas C would be a monomial because it's 1 term. All right, so again, an example of a binomial, it's the sum of 2 monomials, something like 2x plus 3, as long as you have the terms separated by addition and subtraction. Okay, a trinomial will have 3 terms, so we can have something like x squared plus 2x minus 5. Okay, now we need to talk about the degree of a monomial. So degrees have, we have to look at the sum of the exponents of all of its variables. Degrees of monomials, let me just give a very basic example. If I have 2x squared, all I have is one exponent. This degree would just be 2. If I have something like 3x, what's that variable's exponent? Since it's not written, remember we put that in that little 1. This degree would be 1. Okay. If I just have a number, say 5, notice we don't have any variable. You can kind of think of that as x to the 0 power. There is no exponent. This degree is 0. Okay. So these are all examples of finding the degree of a monomial. Notice squared, 2, 1, 0. Degrees of polynomials, you have to look at basically each of the terms and just take the greatest degree of those. Okay, so meaning if I have 5x minus 3x squared plus x cubed minus 5. Oops, back that up. X cubed plus 5. Okay, so we have 4 terms. We've got 1, 2, 3, 4 terms. You have to look at the degrees of each of those, and it's basically the biggest one. So what's the largest exponent? 3. So this degree of the polynomial would be 3. Now, individually, notice this degree would be 1, this degree would be 2, that's 3, this one's 0. We just need to look at the biggest degree of each of the individual monomials. Okay, so the degree would be 3. All right, so we've discussed the degrees of monomials and polynomials. Now let's look at classifying a polynomial by their degree. Certain polynomials have names. You need to know these. So if I have a 0 degree, like we saw above, just a number, we call this a constant polynomial. Okay, if we have a polynomial that has a degree of 1, I can have something like 3x or 6x minus 1. these are both polynomials that have degree 1. Well, think about what that graph looks like. If we were to graph this polynomial, you know, if it was like y equals, these would be a line, right? So we call this a linear polynomial. All right, if the highest degree is 2, so if I have something like 5x squared or something like 2x squared minus 5x, okay. Highest degree 2, we're going to have a quadratic. We looked briefly at quadratics the last few chapters. Remember, the graphs of these are parabolas. And this can be a little confusing because people look at quad and think it's 4. Just remember, quadratic is a second degree polynomial. That can be a little confusing. All right, anything to the third power. Something like x cubed plus 5. This is going to be called a cubic polynomial. Okay, a fourth degree. I'm getting tired of writing examples, so anything to the fourth degree is called a quartic. Okay, so quartic, I think like quarter, right? Quarter has four quarters in a dollar. All right. And the last one, anything to the fifth power, is going to be called a quintic polynomial. 6 or more polynomials, degrees. We don't have a special name. You just say a polynomial of 6th degree or 7th degree and so forth. So you do need to know these words. Typically we test them, you know, multiple choice or matching. So just know how to recognize them. Don't get confused between the quadratic and quartic. Those are the hardest. And kind of a preview of IM3, you'll be graphing these polynomials. So you do need to know their names and degrees. Okay. So all you need to do on your assignment tonight is kind of determining whether an expression is a polynomial. And if it's a polynomial, find the degree and determine if it's a monomial, binomial, or trinomial. Okay, so remember our specifications. Which of these are polynomials? They have to have whole numbered exponents. So A is not even a polynomial. Not a polynomial. All of these are. Okay. And what are the degrees and the classifications? Well, the degree of B, remember we look at the highest exponent. That would just be 3. Okay. The degree of C, remember that little exponent that we don't write is 1. That's a first degree polynomial. Don't put 0. Okay, and same thing with D. That would be a first degree polynomial. All right, and then on classification, monomial, binomial, trinomial, we see that this has 3 terms, 1 term, 2 terms. So just make sure you know those words. Trinomial, monomial, and a binomial. So this is classifying a polynomial by the number of terms. Again, it'll be matching or drop down on your homework tonight, but if they ask to classify it by the degree, then they'll give you choices like quartic, quintic, quadratic. This one, since the degree is a 3, that would be your cubic. Okay, so this is called a cubic trinomial. This one would be a linear monomial. You can use both of those words. And this is a binomial, but it's also linear. It's a linear binomial. All right. Next page. Okay. Now we want to talk about writing a polynomial in standard form. So standard form means we want to write each of the terms in order from greatest degree to least degree. So notice this example down here. We want to write it so that the highest degree goes first. So we're going to put this one first, Then write this one second because we're looking at the cube, 2, 1, and so forth. Why we want to do that is once a polynomial is written in standard form, we can discuss what is the leading coefficient. Okay, coefficient is just a fancy word for the number in front of a variable. You need to know that word. Okay, so when a polynomial is in standard form, the coefficient of the first term is basically the leading coefficient. It's basically the first term. Okay, so when we write this in standard form, we are going to take 2x cubed will be the first one. Then we take the second term, the next highest power, to be minus 3x squared. And then plus 4x plus 12. Go in that order. Okay, so this is standard form. After we do that, we can identify the leading coefficient, which is basically the term in front, but the coefficient is just the number. So the leading coefficient is 2. Okay. All right, not very exciting, but you'll see why that's important when you're graphing these polynomials when you get to IM3. All right, now we get to add and subtract polynomials. You may have done this in previous terms, but when we add or subtract polynomials, we can only add like terms. Now, what makes something be a like term is they have to have the same variables and exponents. Okay, so remember, we can take 2x plus 3x, that's going to be a 5x. But if I have a 2x plus an x squared, these are not like terms. You can't add them. Okay. All right, so we want to find each sum or difference. Write your answer in standard form. So highest degree to lowest degree of each of the monomials. Okay, so notice this can be confusing for some students. We have parentheses here. That does not mean multiplication. It's just separating this addition sign or subtraction sign, which I think can be confusing with the addition. We really don't need the parentheses when I have this addition. But it's super duper important when we have this minus sign because math teachers are evil, and we will have to remember to distribute that negative. But this is a pretty straightforward problem when we have plus. We're just going to combine our like terms and be very careful with our signs. So we have our y squareds that can be combined, which will be 7y squared. Next, we can combine our 12y with a 1y, making 13y. And last but not least, we have minus 2 plus 10, which will be minus 12. Now notice I have written this in standard form, highest degree to lowest degree. And if I ask you what the leading coefficient is, that would be 7. Okay. I could also ask you to classify it. This is a trinomial, and it's quadratic. Okay. All right, the next one, we have that evil negative sign. So when you see parentheses and subtraction, what some students like to do is put a little 1 there, and remember you're distributing or multiplying each of those terms by a negative 1. Doesn't change anything in the first parentheses, but when I distribute that negative 1, I'll have minus 5h squared plus 2 minus 8h. And then we can go about adding our like terms. I like to start with my highest degree first. So the first term should be negative 6h squared. Then we have we have 3 of these. Minus 2h plus h minus 8h, which should come out to minus 9h. And then we just have our last term, plus 2. Written in standard form once again. Okay, so that's all you need to do today. Good luck on the assignment, and I'll see you guys tomorrow.